Hello, today we're going to visit the constant of proportionality in tables. We're also going to relate it to the equation that we talked about the other day. And we're going to go back and revisit a couple things that we talked about. So when we talk about the constant of proportionality, it also is the unit rate. And we've been working on this for a while. Unit rate is the amount for one, the amount of the first item for one of the second item. We also mentioned that it has another name. It's called the K value, and we find it by the K value by taking any Y value in a table over the X value. And then finally, we're going to relate it back to an equation, and the equation officially looks like this: Y equals KX. Y is one of the values in the table, and X is the other value in the table, and the K is this constant of proportionality that we're going to figure out by using a Y value and an X value. So before we begin, I also want to mention that since it's a constant of proportionality, everything, all of these tables are indeed proportional, and later on we'll talk about non-proportional tables. So let's go ahead and begin. It says determine the constant of proportionality, which is also known as K, for each table and write the proportional relationship between X and Y. And so we're going to use, when they say write the proportional relationship, we're going to show this equation. So because we know that these are proportional tables, we can use any one of these values. And I'm actually going to start with 2 because this is going to give us a whole number constant of proportionality. And by the way, you might want to use an extra sheet of paper because I think for my purposes I might need more room to work. So since I can choose any X and Y value, or Y and X value, I'm going to go ahead and remind myself I'm trying to find the constant of proportionality. So I pick a Y value and its corresponding X value. So it doesn't really matter, so I'm just going to go ahead and choose the first. So the Y value is 63 and the X value is 9. And if I simplify that by taking 63 divided by 9, I'm going to get 7. But I also want to acknowledge that this 63 over 9 could also be written as 7 over 1. And so that's important because 7 would be a Y value and 1 would be the X value. So these are equivalent, like equivalent fractions. So 7 would be considered the constant of proportionality, simplified. But I also want to acknowledge that if you are ever given 1 and an X value, the matching Y value is also going to be your constant of proportionality. So we can say that our K value, or the constant of proportionality, is 7. And I also just want to let you know where I'm going to write it like 7 over 1 for a minute because we're going to talk about that for the next one. So the other thing they ask us to do is write the proportional relationship, and they're talking about the equation Y equals KX. Well, we now know what K is. So I can write this as Y equals 7, where the K is X. So what that's telling me is I can take any X value, any one of these X values, and take 7 times whatever that is, and it's going to give me back Y. So let's try that. 7 times 9 would be 63. 7 times 4 would be 28. 7 times 2 would be 14, and 7 times 11 would be 77. Now, this is the official way that they write this equation, but the ironic thing is we use it probably in a different order. I was saying 7 times the X values would give me back the Y values. So this, although this is more comfortable, this is the way that they're going to write it, and when you see other videos and in a book. So now I'm going to ask you to move back to number 1. As we look at the table for number 1, I'm noticing that the y values are smaller than the x values. So when I go to find my unit rate, my constant of proportionality, once again, I'm going to start with y over x. I'm going to choose any x value and any y value. So I'm going to go ahead and just choose the first one. It really doesn't matter since this is a proportional table. And that's going to give me 4 over 10. Now, if I took 4 and divided it by 10, that would give me a decimal. The calculator is going to default to a decimal, but we'd like to keep these in fraction form. So I'm going to ask you now to take your calculator, and I'm going to show you something that might help you. On your scientific calculator, if you enter this ratio of y over x as a fraction for ABC 10, so let me go ahead and write what I'm doing. I'm taking the numerator, ABC, and then the denominator, and if you just press enter or equals, it's going to give you the reduced form of this. So it would be 2 over 5. And if you do that with any of these y over x values, it's going to give you the reduced value. So it turns out that the k value in reduced form, left in fraction form, would be 2/5. So our k value, our constant of proportionality, is 2/5. And if I put this on the table, it would mean that 2/5 would be in the y column for 1 of whatever x happens to be. Now they didn't label x and y, but it means 2/5 over 1. And once again, if you wanted to prove this is true, if I took 2/5 and divided by 1, I'd get back 2/5. So the equation, the relationship that this gives us using this equation, y equals kx, would be y, and where the k is, we're going to replace it with 2/5 x. So once again, let's see if this actually works. Using your calculator, would you please enter 2ABC5, and let's go with the first value of x, times 10, because side by side means multiply. When I have 2/5 next to x and I'm using this first x, it means to multiply. And when I press equals, I indeed got 4 back. Let's try that again. This time, let's put 20. So we're going to clear our calculator and put 2ABC5 times 20. And when I press enter, I indeed get 8 back. So if I took 2/5 times each one of these x values, I would indeed get back the matching y value, just like the table before when we took 7 times all the x values, we got back the y values. So for the purpose of this exercise, what I'd like you to do is I'd like you to find the k value for every table. Some will be fractions, some will be whole numbers, and I'd like you to also write the equation. So would you please try the next 6 tables, and I've also included the key because I know this is brand new. I want you to be able to double check your work. So thank you very much and enjoy the rest of your afternoon. Bye-bye.